Okay, good morning, geometry students. Looking into 8.5, Law of Sines and Law of Cosines. This will be our last new section of material that we have for this school year. Okay, this here allows us, we've been working hard with sine, cosine, tangent, which is specifically for right triangles. But as you know, there are triangles out there that are not always have a right angle measurement. They also have they're acute triangles, they're obtuse triangles, so on and so forth, and this allows us to find them. So looking at your textbook here, and my notes, I have it as well. That's been uploaded to Google Drive, but the textbook has it a little bit laid out here better, so that way I can explain it to you. Starting out with the law of sines. Okay. First things first is to see this equation right here. Sine of capital A, which is an angle measurement, notice is opposite side of lowercase a. Angle opposite of the side length, and same with B and C with C. One thing is you will never use all three of these at once. You can't have two equal signs in an equation. So it'll always be, what it's saying is it's just a comparison of the ratios. Okay? It doesn't even necessarily matter if you worry about A or B or C. It's the fact that you have to have sine of an angle over a letter, over a side length, equals sine of an angle over another side length. And you'll see it kind of right here with an example problem in DF and EF. Okay? Sine of an angle over a side length, sine of an angle over a side length. So that is very important to understand. You're not going to actually be using all three of these at one time. Now, when can you use the law of sines? This is important. You can use the law of sines to solve a triangle if you are given two angle measures and any side length, or you are given two side lengths and a non-included angle measurement. Okay, so here are two angle measures and a given side length. Here are two side lengths and a non-included angle. Non-included angle, remember, is an angle that does not fall between the given side lengths. So in example 2, they provide you a really good example of how to find a side length and how to find an angle. Again, you're still using sine, cosine, tangent, and their inverses depending on if you're finding a side length or an angle. So check it out here. I've got two example problems I'm going to do for you. Okay, starting with the law of sines. So in the law of sines, notice we are given two angle measurements, 39 degrees and 88 degrees, and a given and a side length. So if you're given two angle measurements, the first thing I want you to understand is you can go find that third angle measurement. And that's going to be, let's see here, do a little math. We've got 39 plus 88. Brain's not quite working this morning. 39 plus 88 is 127. So that means that this angle measurement right here is 53. Okay, do you have to find that? No. But it really helps out sometimes just to have that complete idea of what all the side lengths are. So we have 39 degrees, this opposite side length. If we look back here at the text, notice the sine of an angle must go with the opposite side length. So the sine of 39 all over 22 equals, now this is the x that we're looking for. We're looking for NP. Opposite, it's 88 degrees. So sine of 88 all over x. Okay, we have a proportion. Cross, multiply, and divide. So we've got x sine of 39 equals 22 sine of 88. And then divide by sine of 39. Okay, and we get the x equals, and this is just a calculator operation, 22 times the sine of 88. Divide that by the sine of 39. And you get, and we're rounding this to, this is angle measurements because we're doing, I'm sorry, this is a side length, given a side length here. 34.9 it is. X equals 34.9 in its units. Okay, so it's all about setting up that proportion. Now, how about an angle? Okay, again, we are given two side lengths and a non-included angle. The reason this works is because we have to have one ratio set up. So we got to go sine of 125 divided by 10 equals the sine of our unknown divided by 6. And it's 6 because it's opposites. Sine of this angle divided by the opposite. Sine of this angle divided by the opposite. That's how you always set up your ratios. We can go ahead and cross multiply and divide. So we get 6 sine of 125 equals 10 sine of x. Move 10 over. Sine of x equals 6 sine of 125 divided by 10. Now, because we're finding an angle measurement, this is where we have to multiply by the inverse to each side. So sine of -1, we're going to times everything by that. That leaves me x equals the inverse sine of everything, 6 sine of 125 divided by 10. And that'll be a calculation problem. Inverse sine of 6 sine 125 divided by 10. And, oops. Working on the calculator here. Six sine of 125. Divide that by 10. Take the inverse sine of that. 29 degrees, since it wants you to round it to the nearest whole number. 29 degrees. Okay, so 6 times the sine of 125, divide that by 10, take that answer, and take the inverse sine of it. All right? So that is law of sines. Remember, you're only ever going to use two of the ratios, setting it up and solving. In a minute here, I'll do law of cosines for you. Thank you.